Picture yourself staring up at the night sky, where the vast expanse of stars and planets twinkle like cosmic beacons, each one of them a mystery, a chapter in a story written across billions of years. Now imagine this. Amidst that vast silence, a signal is detected. Not just any signal, a structured, deliberate emission that seems to whisper secrets from a distant world. A signal that could forever change how we perceive our place in the universe. This is no science fiction tale. This is the story of Europa, one of Jupiter's enigmatic moons, and the source of a phenomenon that has left scientists scratching their heads. Europa, a frozen world encasing an ocean beneath its icy shell, has always been one of the most promising locations in our solar system to search for alien life. And now, with the detection of this strange signal, it's thrust into the spotlight like never before. What does the signal mean? Is it a natural occurrence? Some intricate interaction between Europa's ice and Jupiter's powerful magnetosphere? Or could it be something entirely unexpected, perhaps even artificial? Today, we'll dive into the depths of this mystery, exploring how this discovery was made, what makes Europa so unique, and why this signal has scientists and dreamers alike holding their breath. Join us as we venture into the unknown and ask the ultimate question. Are we truly alone in the universe? Or is Europa the first hint that we've been sharing this cosmic expanse all along? The discovery began quietly, almost unnoticeably, during a routine scan of the skies. Astronomers were using one of Earth's most advanced radio telescopes to monitor electromagnetic emissions from celestial bodies when they stumbled upon something out of the ordinary. A faint signal originating near Jupiter stood out from the usual cosmic noise. At first, it seemed like nothing, a fleeting blip that could easily be dismissed as interference or a glitch in the equipment. But as the researchers dug deeper, patterns began to emerge. The signal wasn't random. It pulsed in a way that suggested precision, as though it were following some kind of deliberate rhythm. What made the discovery even more astonishing was its source, Europa. This icy moon, long suspected of harboring a hidden ocean beneath its frozen crust, has been a focus of scientific curiosity for decades. But no one expected this. The signal appeared to be emanating from either Europa's surface or somewhere slightly below it. The confirmation came quickly. NASA's Juno spacecraft, already orbiting Jupiter and conducting detailed studies of its moons, recorded electromagnetic anomalies consistent with the ground-based detection. The data didn't just confirm the signal, it raised even more questions. What could generate such a distinct, patterned emission? Was this a natural process, or something far more intriguing? To understand why this discovery is so significant, we need to talk about Europa. Europa isn't just another frozen moon drifting aimlessly through space. It's a world that could be teeming with possibilities. Beneath its icy surface lies a vast, salty ocean, a body of water so immense it contains more liquid than all of Earth's oceans combined. But water alone isn't enough to make Europa a candidate for life. What makes it truly special is the heat generated by tidal forces. As Europa orbits Jupiter, the immense gravitational pull stretches and compresses the moon, generating heat through friction. This process keeps the subsurface ocean in a liquid state and could create hydrothermal vents on the ocean floor. Here on Earth, hydrothermal vents at the bottom of our oceans are hotspots for life. Entire ecosystems thrive in complete darkness, relying on chemical energy rather than sunlight. If similar vents exist on Europa, they could provide the perfect environment for life to develop, even under miles of ice. Europa's surface, with its cracks and streaks, is another clue. These fractures suggest the ice is constantly shifting and breaking, potentially allowing materials from the ocean below to mix with the surface. It's through these cracks that water vapor plumes, detected by spacecraft, are expelled into space, carrying with them the chemical fingerprints of what lies beneath. And now, with this strange signal, Europa's story grows even more compelling. Could this icy moon be home to more than just water and chemistry? Could it harbor life advanced enough to send out signals? Or are we witnessing a natural process that we've never seen before? So, what exactly is this signal? Scientists are working tirelessly to decode its origin, and several theories have emerged. Let's explore the possibilities. One explanation could be natural electromagnetic activity. Europa, like other moons in Jupiter's orbit, interacts with the planet's powerful magnetosphere. These interactions can create electromagnetic waves. However, these waves are usually chaotic and unpredictable, unlike the structured nature of the detected signal. Another possibility is geological activity. Europa's surface is known to crack, shift, and refreeze. This activity could create vibrations or electromagnetic disturbances. Yet again, the precision and rhythm of this signal don't align with the randomness of such geological events. And then there's the most exciting hypothesis, that the signal is artificial. If life exists beneath Europa's icy shell, it might have developed ways to communicate or generate energy, either intentionally or as a byproduct of its activities. Could we be hearing the echoes of alien technology, or perhaps a biological process we've never encountered before? The truth is, we don't know yet, but the implications are profound. If this signal is more than a natural phenomenon, it could represent one of the most significant discoveries in human history. The discovery of this signal has launched a new wave of exploration and curiosity. NASA's Europa Clipper mission, set to launch soon, will bring us closer than ever to unraveling Europa's mysteries. With its advanced instruments, the Clipper will fly by Europa dozens of times, analyzing its ice, atmosphere, and potential plumes for signs of life. Meanwhile, the European Space Agency's JUICE mission will provide complementary insights, studying not just Europa but its neighboring moons Ganymede and Callisto. Together, these missions represent humanity's most ambitious effort to explore the Jovian system. But the ultimate dream is to one day land on Europa, drill through its icy crust, and explore the ocean below. It's a technological challenge unlike any we've ever faced, but the rewards could be unimaginable. Imagine the first images of an alien ocean teeming with life, or the discovery of entirely new forms of biology. It would redefine everything we know about life, evolution, and our place in the cosmos. This mysterious signal from Europa is more than just a scientific anomaly. It's a reminder of how vast and unexplored the universe truly is. It challenges us to keep looking, to keep asking questions, and to embrace the unknown. Whether this signal is a natural phenomenon or a hint of something extraordinary, it has reignited our collective curiosity. Europa, once a distant and icy moon, now feels like a potential bridge to understanding our cosmic neighbors. So, what do you think? Could this signal be evidence of life beneath Europa's ice? Or is it a natural process we have yet to understand? Whatever the answer, one thing is clear: the universe is far from silent. It's speaking to us in ways we're only beginning to hear. Join us on this journey into the mysteries of space. Like, subscribe, and share your thoughts in the comments below. Until next time, keep your eyes on the stars, because the answers we seek might just be out there, waiting to be discovered.